Okay, so for this question here, it's a very specific linear acceleration question, and it's motion under gravity, and this comes up time and time again. It's very, very popular for these questions. So the important thing to notice is that gravity has a value of 9.8 meters per second squared, and that it acts in this direction here, towards the centre of the Earth. So with this question, when you read through it, it's a stone is thrown upwards with a speed of 5.4 meters per second. How long does it take to reach its maximum height? Well, this here tells us that we know its initial velocity. So I'll write in our variables, u, v, a, s and t. Now, we know the initial velocity is 5.4 meters per second. We also know that the acceleration is 9.8 meters per second squared. That's the acceleration due to gravity. Now, because our initial velocity, and I'll just draw a vector for it, we'll take our initial velocity is upwards at a value of 5.4 meters per second. We know acceleration g is downwards at 9.8 meters per second squared. These two vectors have opposite directions. Now generally we always take up as positive and down as negative. I think it probably comes from sea level, or if you think about temperatures or anything, generally up is positive, down would be negative. If you look at a y-axis on a graph, up would be positive, down would be negative. So we will, and it's really important to include this, is that acceleration, our value is minus 9.8. Now the second thing to notice about this is that, well, to pick out the thing we're looking for the time. There's no mention of the maximum height, the actual distance, it's how long it takes to reach its maximum height. Now when anything is thrown up into the air, so if it's thrown up into the air, what will happen is that it will gradually go up. It'll start off fast, slow down, slow down, slow down, slow down, slow down, slow down, eventually reach its maximum height, stop for an instant, and then starts coming back down. So what we're interested in is a journey from here up to here. And the special thing about its maximum height is that up here the velocity be equal to 0 meters per second. So we can put that in as well. V, the final velocity at its maximum height, is 0 meters per second. Now that comes out quite a lot, so it's a bit of information that they've given us, but it's not obviously given to us. So we write out our three equations. V is equal to u plus at, v squared is equal to u squared plus 2as, s is equal to ut plus 1/2 of at squared. We're looking for time. We've got those three. So in this instance, we want to use this first equation. Fill in the numbers we have. We know 0 is equal to u, which is 5.4, plus at, which is minus 9.8 times time. Bring this over. You get 9.8 t is equal to 5.4. Divide both sides by 9.8. You get t is equal to 5.4 divided by 9.8, which I think works out to be roughly, exactly, 2. What is it? At works out to be, let's use the calculator there quickly. 5.4 divided by use a different calculator. 4 divided by 9.8, and we get 0.55 of a second.